Action. Okay, so today we are going to be talking about analyzing quadratic functions. And you'll notice that it's part 1 of the lesson, which means that tomorrow part 2 is coming. So the big thing to remember about this is that it's important that you understand what we're talking about today, or else tomorrow is going to cause you a world of hurt. But it's not too complicated yet. So the quadratic function is when we can write the function in this form, this ax squared plus bx plus c. So there's nothing to be scared of. We see equations like this all the time, right? The quadratic equation is just when you have that entire equation equal to 0. So that would be good for something like finding roots or zeros or x-intercepts, right? The one thing that we have to deal with today is that these equations can be written in 2 forms, the general, which we're used to, and the standard, which is the one we're going to be using today. No. Yeah. So, but today you'll learn to love the standard form because there's a lot of things that you can tell about this equation just by looking at the standard form. So, it's a good thing. So you can skip to page 303. And what we're going to be talking about is transformations. So a transformation is just a graph that's been moved. So if we look over here, here we have f of x is equal to x squared. And here it is here. But if we're given something like this where it says y is equal to f of x plus 3, we can just replace this f of x with the x squared because we were told up here that's what it equals. Okay. So what would this one be, the next one? You got it. Okay. So in our graphing calculator, in y1, I'd like you to put x squared, and in y2, I'd like you to put x squared plus 3. Okay. So what are some things we notice about the x plus 3 graph? If it's not exactly the same, press zoom 6. And that'll make our windows the same. Got it, Andrew? Okay, then go check your... Okay. So this one right here is our x squared. And this one is our x squared plus 3. So what do we notice about our x squared plus 3? How is it different? Moved it up 3 spaces. Because we know that our x squared is the one where the vertex is at 0. Okay? So, let's fill in this graph here, or this chart here. So we'll go y is equal to x squared plus 3. So what's the vertex of our new graph? You got it, 0 and 3. Okay? And so our minimum is still 0, right? And the axis of symmetry is just where the graph is split in half, like here. So has our axis of symmetry changed with our new graph? No, it's still x is equal to 0. And so you have to be able to describe this in words as well. So we would say it's a vertical translation because it goes up and down. And how many units has it moved? 3. And in what direction? Perfect. Okay. So on these graphs, we say up and down. We don't have to say north and south. Okay. So I bet we could do the f at x minus 3 without even looking at the graph, right? So what is the vertex of a graph where it's x squared minus 3? 0 and negative 3. Thank you, Andrew. Okay? Yeah, sorry. 3 and negative 3. And would our axis of symmetry change or stay the same? Stay the same, right? Because all we've done now is that we've moved our graph down 3, like this. Okay. And then how would we write this in words? Okay, so I'm just going to write VT, and then, yep, 3 units down. You got it. So, probably. Okay, so if you go down to E, this is like going to be your big notes on this section. So maybe throw some stars next to it. So I'm going to give you some advice right now that will help you for the rest of this lesson and in grade 12. Yeah, so take a letter. Okay, so if you look here, they have it written as x squared plus q, where q is like what our 3 was, right? It can be anything. Because this changes the y values of our graph, change it to minus q. Y minus q is equal to x squared. Okay? Because it's just easier if we keep everything that's dealing with y with our y, right? So you would have to change it. If you were putting it in your calculator, you'd have to put it back. But on paper, this will help to keep it organized in your mind. Yeah. It's a Q. Yeah, that would make it really confusing if you thought it was a 9. Yeah. Okay. Focus. Focus. I didn't write the test, I'm sorry. Okay? So, for our notes, a vertical translation or shift of Q units. So, ready? Okay. So if Q is greater than 0, our graph moves up. If Q is less than 0, the parabola moves down. A parabola is just this shape. No, this is a parallelogram. A polygon and a parallelogram are the same thing. Okay. So, the reason that we want to keep this Q on the side of our Y comes up next, because next we're dealing with our X's. I know. So, Justin, good sound? Are you guys ready? Okay, so here we have fx plus 3. Whatever is inside of these brackets can substitute for x. So here we're going to go have y x plus 3 squared. Just like that. Because it's squared here. Yeah, because they're asking us to write an equation. An equation has y. Nope, because this is replacing the x. Okay, so everything inside of the brackets replaces the x. So on this side, x minus 3 squared. So we're going to do something similar to last time. In y1, I want x squared, and in y2, I want x plus 3 squared. Okay, so we'll go. Yep, Aaron? Just because that's the example I'm doing. You can do the negative one if you want. It's just an example for your notes. It's just because well, it's just like y is equal to x squared, so I make x1 or x squared y1, and then I just want this one too, so I make it y2. Okay? This one. Shouldn't.
Oh, I got 2.
Okay, so our graph should be moved 3 to the left now. Okay. This is what I put. Okay? So if you're not getting these graphs, make sure that you have brackets around your x plus 3, or else they might be putting in x plus 3 squared, and that'd be like x plus 9, right? So make sure that you have brackets around your x plus 3. So one thing you'll notice is that in your textbook they write it like this, with x minus p squared. Always try to write this with a negative sign here. So you can write this like y is equal to x minus negative 3. Because you'll notice that here we have a plus 3 moves the graph to the left. And intuitively, we tend to think that plus or positive means moving it to the right. Right? So, but if you write it like this, you can see, oh, we have a negative 3 there. It moves to the left. Because this is like that little mistake that you'll miss on a test, sort of thing. So you always want to write it so that it's x minus something, even if it's minus a minus. You know, if it's x minus positive 4, like if it's like y is equal to minus like this, that would move it to the right because our 4 is positive, even if our sign is negative. Yeah. Okay. Okay, so let's fill in this graph or this chart. So we'll go x plus 3 squared. So where's our vertex on our new graph? This. I'll also write it like. You got it, 0 and negative 3. Or actually, negative 3 and 0. Okay. And this, when we write it like this, where we always have that minus sign, it's handy because this automatically becomes our x value. So we know that that's from there. Okay? Has our minimum changed? Nope. What about our axis of symmetry? Yeah, the minimum is the lowest that it goes. So it hasn't changed. It's still at 0, right? But our axis of symmetry, which was here before, is now here. You got it. So if we were to describe this in words, we would say that it's now a horizontal translation. And then it's 3 units left. You got it. Okay. And then if we were to do the next one, we could say y is equal to x minus 3 squared. And we can also write it kind of like minus positive 3. That way you know for sure that you're moving in the positive direction of right. So here, 3 and 0, because we know that that number is there. Our min doesn't change because we're not moving it up or down. What about our axis of symmetry? Plus 3. Yep. So the vertex. Like that. And then for this one, we can go a horizontal translation of 3 units right. Okay. So if we go down to E, we can say that it's a horizontal. And then if P is greater than 0, so this is like y is equal to x minus p squared. So if P is positive, it moves to the right, even though there's that minus sign there. And if P is negative, the parabola moves to the left. Okay? Pardon? No, because you get different shapes of graphs and stuff, so, but right now we're dealing with parabolas. Okay, so if you flip to the next page, now we get to put it all together. So we have our equation here now. So it has both P's and Q's. So we're moving up and down and left to right. Oh, sure. Okay. So remember, we can rewrite it like this. And that way we know that everything with our y's is on one side, Andrew, and everything with our x's is on the other side. That way there's no way you can get them mixed up. Yes, Aaron. Is there a question? Okay, perfect. So if we have f at x plus 2 minus 4, if I wanted to write that as an equation, how would I write that? Knowing that this is our f of x. You got it. Is this written in our form with the minus sign? No. So we want it. Okay. Remember, because we always want a minus sign here, and we want one here as well. Okay. So the reason that we do this is because if you look at B, it says predict the transformations. So automatically, you can look at this and say y moves down 4 because it's a negative 4, and x moves left 2 because it's a negative 2. Okay, so we'll go 2 units left, vertical translation 4 units down. So this is one of the reasons why we write it in this form, because all you have to do is glance at that and say, oh, negative 4, negative 2, 2 left, 4 down. Instead of being like, oh, x plus 2, but plus doesn't mean right, it means left this time. So this can just kind of clear things up a little bit. So let's put that in our chart so we have a nice example. And we can also write it in our other form. Like that. So what would our vertex be? Negative 2, negative 4. Because we can pull those right from here. Okay. And what about our minimum? Yeah, min is negative 4. Our axis of symmetry? Yeah. And then our transformation is going to be the same as we had up here. So okay. So I know it makes more sense when you kind of put it all together in the end. So this is, like, you can see why it makes so much sense to write it in this form, because it's like, boom, we know that this is the two vertices. We know that our min value is negative 4. We know that our axis of symmetry is negative 2. Yep. Because in your y1, you can't have anything but y on that side. So that's exactly right. Okay? So if we go down to example 1, let's do C. So first thing we want to do is write this in our regular form, right? So we want to get, or the regular form that we were talking about today where we have our minus signs, right? Yeah. And then is our x side okay? Just like that. Yeah, because we started with a positive there, so it has to be y minus negative 8. So they ask us to describe. So when a question asks you to describe a graph, that means they need you to tell us in words. So all you have to do, when it's in this form, it's super easy. You know, it's vertical translation 8 units down, horizontal translation 5 units left, or right, sorry. 5 units right, because it's a positive here. Okay, so if we go to example 2, we'll do B together. And so in this one, we're doing the opposite, right? They give it to us in words, and then we have to write the equation. So, Sam, keep your hands to yourself. Did you catch that, YouTube? Sam, let's keep his hands to himself. So, we want to, you can even set this up before you even look at what our translation is. You can start writing the equation. So we know that it's y minus something and x minus something squared. Yeah, and these types of questions. Because it starts right here, it says it in the question, y is equal to x squared. Okay? So then it says a translation of 6 units down. So we know that this is a negative 6. There's 4 units left. So we know that this is a negative 4. And so when this is like a question on a test or something, we would like you to put it in a more simplified form, right? So you can write as your final answer, like start with this, but then you can write, okay, y plus 6 equal to x plus 4 squared. But if you don't start with it like this, there's a good chance that somewhere on that test you're going to flip a negative and a positive, right? So, exactly. So, we'll go down to number 3. And so it says, on our graph, y is equal to x squared, we have 2 points, 3 and 9. And then it says we have a translation of 2 units up and 7 units to the right. And then so all they're asking is where these points have moved to. So we can go 2 up. So if we move this point 2 points up on the graph, where would it be? Remember, this is our x, and this is our y. Exactly. And then the next thing we do is move 7 units right. You got it. So this is the same if I was like, oh, I need you to move that desk, 3 feet up and 2 feet to the left or something. So in this question, all they're asking for is for you to write the coordinates, so this would be enough. But as a bonus, what would the equation be? So we start with y minus and x minus something. So for 2 units up, what should we have in on our y side? Yep, plus 2. And then 7 units right. We got it. So then it'd be like y minus 2 is equal to x minus 7. And then it's always a good idea also to put it all on one side. Okay? Okay, and that's part 1 of the lesson. So for homework, it's 1 to 6, and there is enough time that you can finish it all in class. So